notice, and this is a typical copyright. We continue with mathematics syllabus for CSEC, which became effective in 2018, and as far as I know, it is still valid. As of December 2025, this syllabus has not been revised, but there are plans to change the structure of the exam from 2028 and onwards. And currently, there are a few pilot projects being conducted in a few Caribbean schools. The two main planned changes to the CSEC level math exam are: one, to split the exam into two parts, maybe a level 1 and a level 2. And secondly, there will no longer be any alternative sections or questions. All sections will be tested. Schedule of videos, as you already know, these first 3 parts have all been published in their entirety on YouTube, all 51 videos. Please make good use of them. Section 4, measurement, 5 of those 17 have been published in their entirety on YouTube. Section 5, statistics, 5 of those have been published in their entirety on YouTube, 5 out of 18. Section 6, algebra, 7 of these have been published in their entirety on YouTube, 7 out of 22. It did take me a lot of time to set up the online school, so I have had to reschedule the last 3 sections of this syllabus. So right now, section 7, relations, functions, and graphs. This is the 8th of 26 videos, and hopefully by the end of this month, February 2026, this should be finished. After that, of course, section 8, geometry and trigonometry, by the end of March 2026. And finally, section 9, vectors and matrices, hopefully April, May 2026. Please note this disclaimer down here. This schedule is just a projection, and it is not to be interpreted by anybody as a contract. Section 1, as I already said, all 33 of these videos have been published on YouTube in their entirety, especially since this section forms the foundation on which the rest of the syllabus is based. Please make sure you look at all 33 and know them very well. Another reminder, you need to know the times tables from 2 to 12, since calculators are not allowed in paper 1. Back to this section 1. Some of these videos are even applicable in primary school for primary school students, teachers, and parents. That is to say, the teachers can use them in the inverted classroom. Parents can use it to help their children. Not that the parents will know the mathematics, but the parents will allow the child to look at it and then ask the child to explain it to them. And of course, the students can look at it before they get to class and after they get to class to reinforce the concepts. So students, teachers, parents can all benefit from these videos, even some of them that are at primary school level. For example, if you consider that section there, notice up here it says add, subtract, multiply, and divide whole numbers. That's video 6. But before you could do that, you have to know about place values, which would be an earlier video, and then add, subtract, multiply, and divide decimals, and so on. You have addition, subtraction, multiplication, and division of fractions, part 1, and then there is another part, and so on. So some of these videos can even be used in primary school, grades 4 and 5 and 6. Section 2, consumer arithmetic. All 12 of these videos have been published on YouTube in their entirety. Section 3, sets. All 6 of these videos have been published on YouTube in their entirety, as I previously indicated. Section 4, measurement. Some of these have been published on YouTube in their entirety, as indicated by these yellow boxes here. The others are only partially published on YouTube. If you need to have full access to these others that are only partially published on YouTube, please see directions in the description below. Section 5, statistics. Again, some of these are published on YouTube in their entirety. Please make good use of those. And then the others that are only partially published, even the partially published one, they do have part of the objective covered there. So you can benefit from that as well. However, if you want to have full access to those videos, please see directions in the description below. Section 6, algebra. 7 of these have been published on YouTube in their entirety, especially since algebra seems to be a problem area with most learners. So please make good use of those 7 that are fully published on YouTube. And then there are others that are partially published on YouTube. Look at those as well. You can gain something from them because part of the objective has been covered in those videos. But if you need full access to those that are only partially published on YouTube, please see directions in the description below. We are now at section 7, relations, functions, and graphs. This section consists of 26 videos from 26 objectives. Before we go on, recall I had said in the introductory video that you will need a good math textbook or maybe a set of 2 to get more practice questions, especially. CSEC recommends the following shown at right, these here. Please pay close attention to the last 2 down here, especially since they form a very good 2-volume set of math textbook that is quite adequate for the current and the future proposed changes in the structure of the CSEC math exam. This is a picture of volume 1, Mathematics, a complete course with CXC questions by Raymond Tulsi. And this is a picture of volume 2. Another disclaimer down here, I get no financial or other benefits from the sale of these books. Also, as of late 2024, a website with AI interactivity has been made available, free of cost, that deals with past CSEC math questions only from paper 2. You can navigate by topics or years, where all questions for the past several years from paper 2 have been worked out for you. If you still have a question after that, you can ask the AI assistant either by text or voice, and most likely that will be explained for you. It is extremely important that you become familiar with how CSEC sets its questions for paper 2 and what will be considered good or correct answers to such questions. This is the URL for that AI website. RSC homepage will be shown on the next slide. This is the homepage for that website. You will have to register first and subsequently sign in. As I said, it is free, so it doesn't cost you anything. This is a URL again. That URL will be in the description of this video below, so you can easily click on it and be redirected to this website. Just a reminder that this formula sheet will be provided for the CSEC math examination papers. This formula sheet here will be provided during the examination. This formula sheet is included in the syllabus. Of course, if you don't have a copy of the syllabus, there will be a link in the description below from where this formula sheet can be downloaded. This is the top part of that formula sheet. And I am going to state the obvious. You do not need to memorize these formulae on this formula sheet, as it will be provided during the examination. And this is the below part of that same formula sheet. While you do not need to memorize these formulae, you do need to know when and how to use them. So we are at section 7, relations, functions, and graphs. This is a print screen of the first page. We have completed these first 5 objectives in this section. Print screen from the second page up to objective 9. We are now here at objective 8. Those 2 have already been completed. Continuing up to objective 13, again print screen. Then up to objective 17, the next page up to objective 20, and then the next page up to objective 22, and finally up to objective 26. Just so you know where we are and where we are going. So we are at objective 8 and we need to reach objective 26 eventually. So section 7, those 7 objectives have been completed. These have been published in their entirety. These others only partially published. And right now, this is video 8. When this is finished, it will be totally published. So we are here, as I said, objective 8. And it says, determine the gradient of a straight line. And you have a little bit of additional notes here. Definition of gradient or slope. That's all we are given from the syllabus on this objective. So let's find a definition for gradient. Before we do that, we will divide this objective, this one video, into 4 parts or 4 sections. In part 1, we will deal with the definition. In part 2, we will determine gradient or slope of a straight line graph. In part 3, we will determine gradient or slope of an imaginary line between 2 points. And finally, in part 4, we will determine gradient and slope from straight line graphs in 2 practical situations to show why it is important to be able to find the gradient of straight line graphs. So part 1, definition. Now, if you look in the syllabus, the glossary of the syllabus, you will see F, graph, and then histogram. So the glossary in this syllabus does not have a definition for gradient. And if you check on the slope, there is nothing there either. So how about that? CSEC does not include a definition for gradient or slope in its syllabus. Let's look at a larger picture of that just to make sure we understand that. F, G, the only thing there for G is graph, histogram, and then hypotenuse. The glossary of this syllabus does not have a definition for gradient or slope. So we will have to look elsewhere. And this is the best definition I could find. The gradient of a straight line is a measure of its steepness, defined as the ratio of the vertical change, which is called a rise, to the horizontal change, which is called a run, between any 2 points on a line. It is often represented by the letter M in equations, especially linear equations. So consider this triangle here. If this height on this side is 5 meters, and this length here is 20 meters, consider the right angle shown above representing the side of an ideal hillside. If you begin climbing this hillside, walking from down here to up here, by the time you reach up here, you would have increased your height by 5 meters, but you would have walked a horizontal distance of 20 meters. I'm not talking about the running distance here. I'm not talking about the distance along this hypotenuse. So Its gradient is the ratio of its rise to its run. That is 5 meters to 20 meters. Or 5 meters divided by 20 meters, and you get 0.25. That is m, the gradient, is plus 0.25. Keep in mind 3 concepts here. First of all, if you go uphill from left to right, the gradient is positive. Even though the gradient is stated as one number, the second part of the ratio, remember it is a ratio, is actually 1. So it is thus 0.25 to 1. For every 0.25 rise, there is a 1 run. For every 0.25 vertical, there is a 1 horizontal increase. And 3, m has no units unless in special cases where the rise and run have different units. Gradient has no unit. It's a single number, which is a ratio. And the single number means whatever that number is to 1. Now, if you look at the mirror image of this over there, we get that. Now, consider the right triangle shown above as representing one side of an ideal hill. If we walk downhill now, from up here coming downhill, notice the gradient is still the ratio of the rise, but you are not going up, you are going down. So now your increase in rise will be -5. You are still traveling 20 meters this way. So it will be -5 divided by 20, and now you get -0.25. So the gradient is now -0.25. That is, for every 0.25 meter you walk this way, you are actually stepping down 1 meter. It is a ratio. Oh, one other thing to think about. The gradient, which is a ratio of rise to run, implies a rate of change of increase in rise to increase in run. It's a rate of change. So that's part 1. We finished with definition. We are at part 2. Determine the gradient or slope from a straight line graph. Now you have a graph, and you have to use this graph to find the gradient. So example 1. Now we have seen this before, so I will move very quickly through this. If you had to plot that graph, you will get this. This is the equation. We already know that the gradient is 2. But let us say we didn't have this, and we didn't have that. Let's calculate the gradient from this graph. So first of all, we will draw a perpendicular and a horizontal from the graph to form a right triangle, ensuring that at least 50% of the graph forms its hypotenuse, and that the x interval and y interval can be easily determined. You do not need to use any of the plotted points, nor any of the axes. So in this case, I am choosing that point up there and this point down here. I draw a horizontal going this way and a vertical coming down that way. They meet here at a right angle. This is the hypotenuse. Determine the length of the vertical from the y-axis, and it is plus if the graph slants upward from left to right, and the length of the horizontal from the x-axis. So if you look carefully at this, you will notice that this y-axis starts out at -2, and it ends -2, and it ends up at +12. So it will be 12 minus -2. So this line here is actually +40. And then this next one here starts out at -3 and ends up at 4. So it will be 4 minus -3. So this line here is 7. So we will divide the increase in y by the increase in x, and we get 14 divided by 7, which is equal to 2, as we did this many times in the last video. So the gradient here is 2. That is how you find the gradient of a graph, a straight line graph. Now, but as I said, from the last video, we already knew that it was going to be plus 2. Now, even though you are given one number, that it is 2, that really means it's a ratio of 2 to 1, meaning the rate of change is at 2 vertical units per every 1 horizontal unit. Even though you're given that the gradient is just 2, please understand that that is 2 to 1. It is a ratio. If you find this video useful and interesting, please like and share. That is to say, like and share. You may also consider subscribing to this channel. Okay, let's look at example 2. We have seen this before in the last video. We know from this equation here that the gradient will be 5. So let us say we didn't have that table there, and we didn't have this here. All we have is that graph. How are we going to find its gradient? Same way as we did for the last one. We will draw a perpendicular and a horizontal from the graph to form a right triangle, ensuring that at least 50% of the graph forms its hypotenuse, and the x interval and y interval can be easily determined. You do not need to use any of the plotted points, nor any of the axes, though you can if you so desire. So I have chosen these 2 points. Now this is a plotted point, and this one, but I am not using any of the axes. So this is the vertical coming down. That's the horizontal going across. They meet at this right angle here. We will consider that right triangle. Determine the length of the vertical from the y-axis, and it will be positive if the graph slants upward from left to right, and the length of the horizontal from the x-axis. So on the y-axis, we are beginning here, which is negative 16, and we are ending up here, which is 14. So we will subtract from 14, we will subtract negative 16. So 14 minus negative 16, and that gives us 30. So this line here, its increase is plus 30. Because remember, we start down here, and we ended up there. Its increase is plus 30. And the x-axis, we started here, which is negative 4, and we ended up here, which is 2. So 2 minus negative 4, and that will give us 6. So this line here is 6, positive 6. Normally, this will always be positive. This one here, the y-axis, we may have positive or negative, depending on how the graph is slanted. So we divide the vertical increase, and I am emphasizing increase for a reason, by the horizontal increase, and we divide 30 by 6, and we get 5. So, you know, that was what we had here from the equation, from the function. But now we have actually calculated it. Remember again that when we say the gradient is 5, that is a ratio of 5 to 1, meaning a rate of change of 5 vertical units per every 1 horizontal unit. It's a rate of change. It's a ratio. And even though you see only one number, it is that number to 1. Example 3, y is equal to negative 2x plus 6. We have seen this in the last video. If we had to plot the graph, this is what we will get. We already know that the gradient here is negative 2. We know that. from this function. But let us say we didn't have this and we didn't have that. All we have is this graph here. Let's go ahead and find the gradient. You draw a perpendicular and a horizontal from the graph to form a right triangle, ensuring that at least 50% of the graph forms the hypotenuse and that the x interval and y interval can be easily determined. You could easily read it off from the graph. You do not need to use any of the plotted points nor any of the axes. In my case here, I am using 2 of the plotted points, but I am not using any of the axes. I could have used this x-axis here, but I'm not. Okay, so let's see how we do that. After we get this right triangle, we determine the length of the vertical from the y-axis, plus if graph slants upwards from left to right, and the length of the horizontal from the x-axis. Well, in this case, the graph slants downwards from left to right. So notice we began here at 14 and we ended up here at -2. So we ended up at -2 and we began at 14. So we will take -2 and subtract 14 from it. -2 subtract 14 and we get -16, not 16. So the length here, the absolute value is 16, but because you are going downhill, it becomes -16, and that negative is important. If we consider the x-axis now, we are starting at -4 and we are ending up at 4 here. So it will be 4 minus -4 and we get +8. So this line here is 8. So we divide the increase in x, which in this case is really a decrease. We divide the vertical increase by the horizontal increase, and the vertical increase is -16, which is really a decrease, divided by 8 and we get -2. Now that -2 is important. When the gradient is negative, it means that the line is slanting downwards from left to right. But remember, I told you, from this function here, from this equation here, we already knew that the gradient is -2, but we didn't have that equation. We didn't have the function. We were only given the graph. And if we are only given a graph, then we need to find the gradient or the slope from the graph without any reference to an equation. So the gradient is -2. That means it's a ratio of -2 to 1. -2 to 1. So the rate of change is -2 vertical units to every 1 horizontal units. As you step down 2 vertical units, horizontally you are covering 1 horizontal unit. Example 4. This is the equation. We have the x domain, the y domain. We plot the graph. We got this. That was from the last objective, last video. We already know that the gradient is -4. But let us say you are not given that. You are not given this. All you are given is this graph. And furthermore, not all those points. You may just be given this 1 point here, that 1 point there, and another one somewhere here. So you would pick the most convenient points for you. Now, I am using this and that, but remember, you may not actually have those points. Choose points that you can easily read off. You could have chosen this one here at 10, because that 10 is easy to read, and this here is actually -3. Could have chosen that point, and this one down here because this point is 4 and this point here is negative 18. Just choose two easy points that you can read off. As I said, you may not be given all these points on the graph. So draw a perpendicular and a horizontal from the graph to form a right triangle, ensuring that at least 50% of the graph forms its hypotenuse and that the x interval and the y interval can be easily determined from the graph, that is, from the axes. You do not need to use any of the plotted points nor any of the axes. Determine the length of the vertical from the y-axis, positive if graph slants upwards from left to right, and find the length of the horizontal from the x-axis. So we are starting here at this point on the y-axis, which is 18, and we are ending up at this point here, which is negative 10. So negative 10 minus 18 gives us negative 28. So this vertical here is really, absolute value is 28, but if we add in the direction, it becomes negative 28. And the horizontal, we started out here, which is negative 5, and we ended up here, which is 2. So it would be 2 minus negative 5, which is positive 7. So the length of that line there is 7, positive 7, including the direction. So all we have to now do is to divide the vertical increase, and I still say increase, even though you see a decrease, by the horizontal increase. So we divide negative 28, which is the vertical increase, which is a decrease, by 7, and we get negative 4. But as I said before, if we had the equation, we would have known that it is negative 4. We get negative 4 as the gradient, which is a ratio of negative 4 to 1, meaning a rate of change at 4 vertical units. Every 4 vertical units that you step down, you have covered 1 horizontal unit. Let's look at that a little closer so you can see what is happening. That was the same example we just did. Negative 4. As you step down 4 units, you actually have to go across 1 to move from there to there, and so on. Notice that the green vertical arrow is the gradient. So this part here to this 1, you are only given that as the gradient, and it applies to the whole straight line graph. If we take the mirror image of that, instead of stepping down, let's step up. Same situation. Now we have y is equal to 4x, not negative 4x, but 4x. Meaning, of course, that for every 4 that you step up, you have to step 1 across. So to cover from here to there, for every 4 this way, you had to go 1 across. And we can complete that almost like a stairway. You have what is called the run and then the rise. Carpenters and builders will tell you that the total distance between that run and rise should be no more than 18 inches. So you may get 11 inches run and 7 inches rise. That would be comfortable for people to walk up. Anything other than that, or anything far from that, will be difficult for people to walk up or down. In that case, it will be 7 to 11. Now, that should suffice for this first and second part, to determine gradient and slope from a straight line, and what exactly does the term gradient or slope mean. Now, we will go over back those 4 examples, but this time we're not given a graph. We are just given 2 points. Of course, we will cover those again so you could see the connection. So we did this already. we got the gradient as being 2. We did this already. But let us say you are not given the gradient, you're just given 2 points. Any 2 points on that line. How do you find the gradient? Let's choose any 2 points from this table at the left here. We could say -3, -2, which is here, and 3, 10, which is down here. Let's choose those 2 points without any reference to the graph. How will we find the gradient? Well, we can think of it, remember now, we can still look at the graph, but we are not using the graph. So that point there to this point here, it is the same line, so we will have the same gradient. We will refer to one of these as x1, y1, and the other as x2, y2. Doesn't matter which one. But generally, you would take the second one as the 2's and the first one as the 1's. But it doesn't really matter which one is which. To find the gradient m, y2 minus y1 divided by x2 minus x1. Here we are. Remember we said we will use this as the 2's. So it will be 10 minus -2, 10 minus -2, divide by 3, which will be x2, minus -3, which will be x1. And when we do that, what do we get? 2, which is the same 2 we got up here, which is the same 2 we had from the equation. If you go the other way around and take that as the 2's and this as the 1's, then it will be -2 minus 10, -2 minus 10, divided by -3 minus 3. Notice you still get the same 2. Either way. But generally, you take the second one mentioned as the 2's and the first one as the 1's. But in doing this calculation, it doesn't matter which one you take as 1. It doesn't matter which one you take as the 1's and which one as the 2's. So given any 2 points on this line, you will get the same gradient. It doesn't matter which 2 points. So we get 2 there, we got 2 there, we got 2 here using this as the 2's, we got 2 here using that as the 2's. Example 2, we are going over the examples we just did using the graph. We know that the gradient is 5. We calculated it already, that the gradient is 5. We calculated it. But now, let's ignore that and choose any 2 points from this table here or from the graph. But you're not given the graph. Let's choose any 2 points, or you are given 2 points that should be on the graph. Let us say the 2 points are -3, -11, and 1, 9. -3, -11, which is here, -3, -11, and 1, 9, which is here, 1, 9. So you're given those 2 points, that one and that one. Now they are still on this line. Using those 2 points, you will get the same gradient, which is 5. So -3, -11, and 1, 9. We will call this second one here the 2's and the first one the 1's. So the gradient m is y2 minus y1 divided by x2 minus x1. So 9 minus -11, which is this, divide by 1 minus -3. 1 minus -3. We work that out and we get 5. But you know, that's what we were saying all along the line. 5 here, 5 there, 5 here. Now, if we go the other way around and use this as the 2's, then we have -11 minus 9 divided by -3 minus 1 and we still get the gradient is 5, positive 5. Now let's go to example 3. This time we know the gradient is negative 2. We did this before. We got negative 2 from calculation. We got negative 2 from the graph. Now let's just take 2 points and do the calculation without any reference to the graph. Say negative 2, 10 and 2, 2. Those are the 2 points we are using. This one here and this one here. We will call this second one here the 2's and this first one here the 1's. y2, which is this 2 here, minus y1, which is that 10 there, divide by x2, which is this 2 here, minus negative 2, which is up there. You work that out and you get negative 8 over 4, which gives us negative 2. Using just 2 points without any reference to the equation or the graph, we still get negative 2. And of course, if you go the other way around, instead of using this here as the 2's, let's use that as the 2. So now it will be 10 minus 2, 10 minus 2 over negative 2 minus 2, and you still get negative 2 as the gradient. So however you look at it, you will still end up with negative 2. And now this is example 4. This is the last example that we have been doing all along the line. We know by now that we should get a gradient of negative 4. We calculated it in the first part of this video, and we actually got a gradient of negative 4 using the graph alone. Now we will just pick 2 points, say 3, negative 14 and 4, negative 18. That is to say this point here and this one down here. They are very close to each other. Normally you wouldn't do that when you are using graphs, but it doesn't really matter if you are using points on a straight line. So we will refer to this last one here as the 2's and the first one as the 1's. So that y2, which is this negative 18, minus y1, which is negative 14, negative 18 minus negative 14, divide by 4 minus 3. And what do we get? We get negative 4 over 1, which eventually ends up as negative 4. You know what? That is what we have been saying all along the line. And even if we let this one up here be the 2's and this one be the 1's, then it is negative 14 minus negative 18, negative 14 minus negative 18, divide by 3 minus 4, and we still end up with negative 4. So either way, or any of these ways, we will still get the same answer, that the gradient here is negative 4. Okay, so we have covered part 1, part 2, part 3. We are left with this last part here. Determine the gradient or slope from a straight line in a graph in 2 practical situations. So example 1. In physics class, you may meet a question like this. A car accelerates from rest to 5 meters per second in 10 seconds. It retains this speed for 8 seconds. It then accelerates to 12 meters per second in 12 seconds. It retains this new speed for 20 seconds. The brakes were then applied and the car came to rest in 8 seconds. That's the situation. Draw a graph to show this journey. That's for physics. And use the graph to find its acceleration during the third part of the journey. And then you may be asked to do some other things with that graph, like finding distance and deceleration and so on. So this is the graph. You have drawn the graph. We have the graph. We are asked to find the acceleration from here to here. That's the third part of the journey. So the acceleration on a speed time graph is actually the gradient of that part of the graph. So you draw a perpendicular here, come down, a horizontal here. M which is the gradient, is the increase in y, which is the increase in velocity, divide by the increase in x, which is time, and you don't have negative time here. So m is 12 minus 5. That's 12 minus 5. That's the increase in velocity. And you divide that by the increase in time, which is 32 minus 18. That is to say, this point here is 32, and this point here is 18. So the increase in time would be 32 minus 18. So that is 7 meters per second, and this here is 14 seconds. You divide increase in y by the increase in x, and you get the acceleration, which is the gradient, which gives us 0.05 meters per second squared. Now note this is a ratio of 0.5 to 1. For every 1 second, the velocity increases by 0.5 meter per second. That is to say, a rate of 0.5 meters per second to every 1 second. Now, you may also be asked to use that graph to find the acceleration during the last part of the journey. Notice I said acceleration. But if you look at the graph, you will see it's a deceleration, but I'm asking you to find the acceleration. So we will get a negative gradient. So we'll find a gradient here during the last part, which is here. We get our right triangle here. We have started at 12 and we ended up at 0. That's an increase in velocity, which is a negative value. And you work through that, you get the acceleration or the gradient. And this works out to be 1.5 meters per second. As a matter of fact, that's a negative 1.5 meters per second. That's the acceleration. Is a negative. The deceleration is 1.5. That is a ratio of 1.5 to 1, but it's a negative 1.5 to 1. For every second, the velocity decreases by 1.5 meters per second. That is to say, a rate of negative 1.5 meters per second for every second. Okay, finally, example 2. The number of life insurance policies sold by insurance company WXY in 2024 is shown in the table at right. Okay, that's the table. January to December. Those are the number of new life insurance policies. Draw a graph for this data, making use of the line of best fit. And once you do that, which we don't have to do in this objective, find the gradient of this line. So this is done by computer. This is the graph. This is the graph. We are even given an equation for the graph. Y is equal to 0.772x. Remember that 0.772 is the gradient. Plus 11.89. That's approximately where this graph would have started on the y-axis. And notice the r-square value is not a very good value. It's far from 1, but that is what we have, and we will work with it. We now need to find the gradient of that graph, of that line. So we draw a vertical here, we draw a horizontal here using easy to read points, because now we are not using any of the plotted points. And so we have to get the increase in y, which is the number of policies, divided by the increase in x, which is number of months. So we're ending at 21 policies, starting at 15 policies from this graph. And we are ending in the 12th month, beginning in the 4th month. So 21 minus 15, inclusive, and 12 minus 4, inclusive. And so 21 minus 15, I know I have 7 here. Remember, we are using inclusive. So if you subtract 15 from 21, you will get 6. But we are using inclusive, so we take 7. And the same thing applies for the 12 minus 4, we get 9. Divide that, and surprise, our answer comes up to be 0.78, which is not very far from this computer-generated gradient. So that is excellent far as I am concerned. That is to say, for 2024, WXY Insurance Company sold new life policies at a rate of plus 0.78 or 0.77 every month overall. Of course, this is not the only policies that the company would sell. They would have car insurance, boat insurance, and travel insurance, and a whole lot of other insurance. But this only applies to life policies. And so the directors of that company can use that data to make meaningful decisions as they move forward. So objective 8, determine the gradient of a straight line. This brings us to the end of video 8 based on objective 8 in section 7. This is an overview of how the videos from this section will be published. Right now we are just finishing objective 8, video 8, and this one will be published in its entirety.